Hello, PreCalc. It's the weekend, so that means we made it through the week. At least a partial week. Next week will be the real test, and we have a whole week. A standard week, Monday through Friday. So rest up this weekend, but enjoy this video as part of your rest. Write this in your comp book so you get credit for it. You should be viewing this lecture sometime after class on the 9th, which is Friday, like maybe Saturday or Sunday as well. Area of a sector is here to amaze us, so let's see if that's showing up. First of all, what is a sector? This should be a word that you've heard of from geometry class. It involves a circle, and in that circle there is a central angle. It looks like that. Notice the sides of the central angle are also radii of the circle. So how cool is that? This radii makes one side of the central angle, and this radii makes the other. This radius makes one side, and this radius makes the other. And this angle created inside is theta. So let me shade in the sector. Alright, so that's what a sector is. It is a piece of the pie. It's the area that is in between the central angle and the arc that it intercepts. And I striped it, and we can just call it a piece of the pizza. So that is a sector, and I was wondering, and I'm sure you were as well, what is the area of the sector? So we'll start building toward the formula instead of just barking it out. We're gonna go into it and see if I can get it out of you. All right, so let's look at the area of a sector that you probably know. All right, so we start with this. So that is a sector, and can you eat that much of the pizza? A quarter of the pizza? I bet you're wondering then what the area is. Let's say that the area of this sector, I'll say area of the sector. So that is going to be figured out by, we know the whole area of a circle is pi r squared, but we do not have the whole area of the circle. We have just this sector, and that sector is exactly 1/4 of the whole circle. So it is probably very clear that the area of this sector is 1/4 pi r squared. So r is the radius, but I didn't give you that. If it's a large pizza, round pizza, then the radius is going to be bigger, and this area is going to be bigger than if it was smaller. So we'll just go in theory for r right now. All right, what about, does it show up down here? I think it does, I think it does, I think it does. Yes, it does, barely. All right, suppose we're having this. Can you eat this much of the pizza? All right, so this time, the area of the whole circle, again, so here's the area of the sector, is going to be pi r squared for the whole thing, but we only are going to eat half of it. So 1/2 pi r squared. Let's go back to this one and then revisit this one as well. If I did another way to find this, when it's not as obvious what the fraction would be, is to think of it like this. How many degrees is it from here to here? It is 90. And how many is it to go all the way around? 360. So do you see that the degree of the sector divided by the degree of the whole circle will give you the same fraction. 90 over 360 reduces to 1/4. More often than not, we'll be working in radians. So does this also work for radians? Well, 1/4 from here to here we learned was pi over 2. And then if we divide that by the whole distance around in radians, it's 2 pi. So how's your dividing fractions feeling today? All right, we'll review that for those who are a little rusty. Just make a fraction of the top and the bottom, and you invert this, and this is y, 1 over 2 pi. If I multiply the bottom by 1 over 2 pi, I have to multiply the top by 1 over 2 pi. Notice 1 over 2 pi is the reciprocal of the denominator. These cross out and become a great fat 1. And up here we have pi on the top, pi on the bottom. So we end up with 1/4 as well. So this 1/4 and this 90 over 360, whether you look at it as radians, you look at it as degrees, or you just look at it with your eyeball, you should come up with the 1/4. Does it work down here? Let's just do the radians. We learned that from here to here is pi radians, and so we are going to take the number of radians in the sector, which is pi, divide it by the whole way around, which is 2 pi, and see how easily we got 1/2 as well. So that's going to work. This little method is going to work no matter if we are familiar with how many radians are in our sector or not. So let me show you. Let's go to this one, where the sector, if you would remember, if anything I draw on the board, that goes in your comp book as well. So not just the conclusion, but everything, the development as well. So here I have a sector of a circle, and I do not know what the radian measure is. It doesn't look like a third, a fourth, or anything that I can identify easily. So here, we will just call the radian measure theta, and we will figure out from there. If we were going to do it this way, the way we did this one, that's still showing up, yeah. We took the amount of radians in that part of the sector, which I gave you as theta, and divided it by all the way around. That's going to give you a fraction that tells you what portion of this area, what portion of the degrees this sector has. So we have a pi over 2 pi. All the way around is 2 pi. 2 hands up. All the way around is 2 pi. Theta is the amount that we went around in our sector. So now that will give us the fraction that we need, that we saw earlier in this problem where there's a 1/2. This will give us the proper fraction, and then it's followed by the whole area. So pi r squared is the whole area of the circle. It's going to be, we only want the portion that this fraction allows. So let's see what happens when we simplify that expression. We have a pi, and so we're left with theta over 2 r squared, and this is the area of a sector, more often written like this: 1/2 theta r squared. So this is only going to work when theta is in radians. All right, which is where we're going to live in trig class. So 1/2 theta r squared is the formula. It goes into the formula area of your comp book, as well as in the place where you're taking notes for today. All right, let's just do one and call it a lesson. All right, give myself some space. All right, I want the formula to still show up, so let me share with the center of the board. I think that's there, good. All right, so let's say we have a circle, and This, we have, say, right here's pi over 2, so let's say 1/3 pi, 2/3 pi, 3/3 pi. Let's do 1/3, 1/6 pi, 2/6 pi, 3. Let's say 2/3 pi. Not 2/3, yeah, 2/3 pi is the angle that we're going to find in our sector, 2/3 pi, and I'm going to find, I'm going to find the area of that sector, this striped part. So I'm going to pull out the formula. The area of the sector equals 1/2 the angle in radians r squared. So the angle is in radians, so I just grab it, 2/3 pi. And I forgot to give you the radius of this circle. This radius is 6 inches. So I'm going to grab that, 6 inches squared, and I'll put the unit in the last step. So this 2 will cancel or cause that 2 to become a 1. So we end up with pi over 3 times 6 squared, 36. 3 goes into 36 12 times, and we get 12 pi, and it was inches. Area will cause that unit to be squared. Alright, so there's our example, there's our concept, and we'll call it a day. Are you brushing away tears from amazement and wonder? When you think about it, you should be. So get those tissues out and be amazed at what you know. Not many people in the whole world can find the area of a sector, but you can. See you on Monday morning. Have a great